Hello everyone, my name is Ajay Medji from Aeronautical Engineering. In this presentation, I am going to discuss about my tech talk topic modes of heat transfer. Heat transfer, which is defined as a transmission of energy from one region to another as a result of temperature gradient, takes place by the following three modes: conduction, convection, radiation. Conduction is a transfer of heat from one part of a substance to another part of the same substance, or from one substance to another in a physical contact with it, without applicable displacement of molecules forming the substance. In solids, the heat is conducted by the following two mechanisms: by lattice vibration, the faster moving molecules or atoms in the hottest part of a body transfer heat by impact sum of their energy to adjacent molecules. Second one, by transport of free electrons. Free electrons provide an energy flux in the direction of decreasing temperature. For metals, especially good electrical conductors, the electronic mechanism is responsible for the major portion of the heat flux except at low temperature. In case of gases, the mechanism of heat conduction is simple. The kinetic energy of a molecule is a function of temperature. These molecules are in a continuous random motion exchanging energy and momentum. In liquids, the mechanism of heat is nearer to that gases. However, the molecules are more closely spaced and intermolecular force come into play. Here the pictures are showing the conduction of heat transfer, the candle to gas molecules, and the ball to the hand, and here the metal to the candle. Steady and unsteady heat conduction. If the temperature of the body does not vary with time, it is said to be steady in state. But if there is an abrupt change in its surface temperature, it attains an equilibrium temperature or a steady state after some time. During this time, the temperature varies with time and is to be unsteady or transient. Steady and unsteady heat conduction. If the temperature of the body does not vary with time, it is said to be steady state. But if there is an abrupt change in its surface temperature, it attains an equilibrium temperature or a steady state after some time. During this time, the temperature varies with time and is said to be an unsteady or steady state. Fourier law of heat conduction. The rate of heat conduction through a medium depends on the geometry of the medium, its thickness, and the material of the medium, as well as temperature difference across the medium. Consider steady state heat conduction through a large plane wall of thickness dx is equal to L and area A. The temperature difference across the wall is dt is equal to T1 minus T2. According to this law, it is concluded that the rate of heat conduction through a plane layer is proportional to the temperature difference across the layer and the heat transfer area, but is inversely proportional to the thickness of the layer. Rate of heat transfer directly proportional to area, temperature difference, thickness. Q is equal to minus K A into dt by dx. The constant of proportionality, the constant of proportionality K is the thermal conductivity of the material, which is a measure of the ability of a material to conduct heat. In this diagram they are showing that the material, the object having some thickness and it has some area A and the temperature T1 and T2 and the thickness delta x. Thermal conductivity solids. The thermal conductivity K is a measure of a material's ability to conduct heat. For example, K is equal to 0.608 watt per for water, and K is equal to 80.2 for an iron at room temperature, which indicates that the iron conducts heat more than 100 times faster than water can. Thus, water is a poor heat conductor relative to iron, although water is an excellent medium to store thermal energy. Thermal conductivity of a material is a measure of the ability of the material to conduct heat. Thermal conductivity of gases. First one, a high value for thermal conductivity indicates that a material is a good conductor, and a low value indicates that a material is poor heat conductor or insulator. In case of gases, the higher the temperature, the faster the molecules move, and the higher the number of such collisions, and the better the heat transfer. Therefore, the thermal conductivity of a gas increases with increasing temperature and decreasing molecular mass. Thermal conductivity of liquids. First one, the mechanism of heat conduction in a liquid is complicated by the fact that the molecules are more closely spaced and they exert a stronger intermoleculation force field. Second one, the thermal conductivities of liquids usually lie between those of solids and gases. Third one, the thermal conductivity of a substance is normally highest in the solid phase and lowest in the gas phase. Fourth one, unlike gases, the thermal conductivities of most liquids decrease with increasing temperature, with water being a notable exception. Convection. Convection is a transfer. Convection. Convection is the transfer of heat within a fluid by mixing of one portion of the fluid with another. Convection is possible only in a fluid medium and is directly linked with the transport of medium itself. It is of two types: free or natural convection. Free or natural convection occurs where the fluid circulates by virtue of the natural difference in the densities of hot and cold fluids. Forced convections. When the work is done to blow pump, the fluid is said to be forced convection. In this diagram, in a ball, the water molecules get heated. The water molecules at the bottom of the ball gets heated and they becoming lighter, and they are moving forward and they are pushing the bubbles in upper of the ball, and they are forcefully pushing them to come down. It is a kind of convection example. Newton law of cooling. Convection cooling is sometimes loosely assumed to be described by Newton's law of cooling. Newton's law states that the rate of heat loss of a body is proportional to the difference in temperatures between the body and its surroundings while under the effects of a breeze. The constant of a proportionality is heat transfer coefficient. The law applies when the coefficient is independent or relatively independent of the temperature difference between object and environment. In classical natural convective heat transfer, the heat transfer coefficient is dependent on the temperature. Newton law of cooling. Convective heat transfer. The basic relationship for heat transferred by convection is Q dot equal to HA delta T minus TF, where Q dot is heat transfer per unit time, A is area of the object, H is heat transfer coefficient, T is the object surface temperature, and TF is the fluid temperature. The convective heat transfer coefficient is dependent upon the physical properties of the fluid and the physical situation. Values of H have been measured and tabulated for commonly encountered fluids and flow situations. Radiation. Radiation is the transfer of heat through a space or matter by means other than conduction or convection. Radiation heat is thought of as electromagnetic waves or quanta as convenient an emission of same nature as light and radio waves. It requires no medium for propagation and will pass through a vacuum. Yeah, in this diagram they are showing the radiation example. The sunlight rays are directly coming into the space like vacuum. They are spreading through a vacuum and reaching the earth. Thanks for watching.